this lesson. And so we're going to find the derivative of a function in this one. So last lesson or last video, we just watched find an equation of the tangent line to the graph of a function. And so again, we're going to do find the derivative of a function. And then that's going to lead us to our last video, which will be find instantaneous rate of change and find the instantaneous speed of a particle. And so again, hopefully there's a lot of connections that you're making between what you're seeing and stuff that we saw when we did average rate of change and instantaneous rate of change. Just to recap, so the slope of the tangent, we now take the limit of our slope of the secant line as x approaches c of f of x minus f of c over x minus c. We're going to evaluate that limit. That gives us the slope of the tangent. Once we know the slope of the tangent, we can then write the equation of the tangent line. Please make your life easier. Use point slope form unless they ask for something else. Okay, don't do more than is necessary. So we're going to pick it up right here, the derivative of a function. So we're going to define the derivative of a function, and we're going to start using derivative notation. So the way we define a derivative of f of x at x equals a, so notice here I'm now going to start using a instead of c. A, c, they're just dummy variables, doesn't matter what you use there. So our notation is this f prime of a, so that's how you read this, f prime of a, or f prime of x, whatever that variable in there is. The other notation you might see is dy dx evaluated. This bar means you're going to evaluate it at x equals a. So dy dx evaluated at x equals a. So there's two forms that we could find the derivative at a certain value of x. So we could say that f prime of a is equal to the limit as x approaches a of f of x minus f of a all over x minus a. This is no different than what we did before. Instead of saying f or slope of the tangent, we're just using derivative notation now. So f prime of a is equal to that. Okay, and so just I want to stress that this here will result in a number. It's the slope of the tangent, right? This is still equal to the slope of the tangent line. Okay. The other way we can do it is actually using that difference quotient, and there'll be a reason why we want to do that at times. So f prime of a is the limit as h goes to 0 of f of a plus h minus f of a divided by h. And so really like what we're doing here is we're saying that h is equal to x minus a. Right? That's really the substitution we're making here to rewrite it in this term. The h goes to 0. Okay? Again, this is the slope of the tangent. Okay? And so the line tangent to y equals f of x at the point a, f of a is the line through the point a, f of a, whose slope is equal to f prime of a. Again, the slope of the tangent is equal to f prime. The derivative gives you the slope of the tangent at a certain point x. So whose slope is equal to f prime of a, the derivative of f at x equals a. We can now write it this way. Y equal or y minus f of a. Again, we're just using point slope form here. F prime of a. This is the slope of the tangent. X minus a. And you could actually go to Desmos and you can type in a function using f of x, and you can calculate its derivative by doing f prime of x. And so Desmos actually recognizes the prime as the derivative. All right, so as mentioned before, try the example on your own. Use this as a guide. Once you're ready to watch the video, press play and see how you did. All right, so in example 3, we're going to find the derivative of f of x equals 2x squared minus 5x at x equals 2. we're going to find f prime of 2. So this means at x equals 2, right? F prime of 2. We're going to find the slope of the tangent at x equals 2. Then write the equation of the line, tangent, at x equals 2. All right, so our first thing is we're going to, just like we did in the last video, we're going to set up our limit. So we're going to find the limit as x approaches 2, and I'm going to use the f of x minus f of a for this example. So f of x is this 2x squared minus 5x minus, now I'm going to find what f of 2 is. All right, so f of 2 is 2 times 4 minus 10. F of 2 is negative 2. So this is becoming a plus 2 now, right? Minus a negative 2, plus 2. So just be mindful of negative signs. X minus 2 in the denominator, okay? So again, if you plug in 0, or 2, sorry, because that's what we're approaching, you'll get 0 over 0. That's a clue to see if you can algebraic manipulate this so that you can possibly remove that 0 over 0. So we're going to factor the numerator. This will factor to 2x, x. So I need two numbers that multiply to 2 and add to negative 5. And so my two numbers will be a minus 1 here and a minus 2. Minus 1 here and a minus 2 here. You can use your diamond reverse box. Here's a clue. I need to get rid of this x minus 2. One of the factors is going to probably be x minus 2. Again, use what you know is probably going to happen to help guide the problem. Right? So x minus 2. And so these will now divide to 1. And so we're left with the limit as x approaches 2 of 2x minus 1. Now I can just plug in 2, and I get 3. So f prime of 2 is equal to 3. Now I can, so now we evaluated that. Now we can find the tangent line, the equation, y minus negative 2, so y plus 2, 3 times x minus 2. And this is the tangent line. Okay. So again, just to remind you, you have to be proficient in factoring quadratics. All right, so there's example 3. All right, so moving forward, now we're going to start talking about the derivative function, whereas here we found the derivative at a value. The derivative function is a function that will provide us with the instantaneous rate of change. It will provide us the slope of the tangent. It will provide us, again, the instantaneous rate of change of f of x at any x in the domain of f, provided it exists. And so the way we're going to do this is we're going to say f prime of x. So again, this is a function. This is important to denote. The other one we used finds a number. This finds a function. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And so recall from our AROC IROC unit, this is our instantaneous rate of change. This is the difference quotient, and now we are applying the limit to do our instantaneous rate of change. Note that the domain of f is the set of all x values such that f prime exists. So what you'll find next year if you're studying calculus is not the domain of the derivative function may be smaller than the domain of the original function. Okay, so it may be a smaller subset of the domain of the original function. All right. So again, this is going to give us a function. That's important. That's that note here. This is a function of x. right? This here, this is a number. Right? This will give you the slope of the tangent at some point A, right? If you compare these two, you'll notice that all we did is we plugged A into that, right? So wherever there is an X, we just plugged an A. F of A plus H minus F of A over H. So this will give us a number. This gives us the rule to find M tangent, or F prime of A at any value X equal to A. Okay, so as long as it exists, we can find the slope of the tangent. We can find the derivative at that value A. Okay, so that's the rule for it. So let's see if we can now compare in example 4. So again, try this. See if you can find the function that we're finding the derivative of and at what value we're finding that derivative. So make a comparison to this f of x plus h minus f of x over h. Compare it with the limit as h goes to 0 of f of a plus h minus f of a over h. Right, so after that, you had some time. We've seen these before. We did this in the AROC, IROC unit. So if I look here, the fact that this is the 1 here, this is a clue. That's my A. And this piece here is also going to tell me the function. I'm raising 1 plus h to the 10th. So A equals 1, and my function then must be x to the 10th power. Okay. Over here, it's slightly different, right? If you remember from earlier in the video, we were talking about how h is equal to x minus a. And so that's what we have here. So in this case, we can say that we're approaching, so our a value is pi over 4. Right? We're going from x to a, and our function is tan x. So you need to be able to recognize from the limit notation what the function is and at what value are we evaluating the derivative at. All right, one more example in this video. Again, try this prior to watching the video. So we're going to find the equation of the line tangent to the graph of f of x at f of x equals 5 over x minus 1 at x equals 4. And then I'm just going to show you how to use the calculator to do this real quickly. So again, we're going to need to find the slope of the tangent. And so I'm going to set up my limit. As x goes to, we're going to go to 4. And then we're going to have 5 over x minus 1 minus, if I plug in a 4 here, f of 4 is 5/3. And that's going to all be over x minus 4. Okay, so again, if you plug in a 4, you're going to get 0 over 0. That's going to be a clue to say, gotta clean this up. All right. And so to do that, I'm going to multiply top and bottom by 3 times x minus 1, 3 times x minus 1. So I'm not changing the value, I'm just multiplying by 1. And so this will equal the lim as x goes to 4 of, when I multiply this first term by 3 times x minus 1, I'm going to be left with a 15 minus 5 times, when I multiply this term by this, you're just left with an x minus 1, all over 3 times x minus 4, x minus 1. So let's clean that up. Limit x goes to 4. Distribute, you're going to get 20 minus 5x over 3 times x minus 4, x minus 1. Note, I don't distribute this. I don't multiply this out because I know I need to get rid of this x minus 4. Right? That's where the issue is. I'm going to need to get rid of that x minus 4. Do not multiply out. Okay, so do not multiply out. Chances are you're going to be able to simplify something. All right, so I'm going to factor out a 5 here. Limit as x goes to 4. I get 4 minus x on the top. On the bottom, I still have 3 times x minus 4, x minus 1. Now, it may look like, we don't have it, but you have to look at these two terms. You have to recognize they're off by a negative sign. So factor out a negative. And now I can rewrite this as x minus 4. Down here, I still have 3 times x minus 4, x minus 1. And so my x minus 4 is now divided to 1. Now I can finally evaluate this. I can plug in my 4 with no issues. I'm going to have a negative 5 on the top. 3 times 4 minus 1 is 3, so negative 5/9 is my slope of the tangent. So now I know f prime of 4 is negative 5/9. Now I can find my slope of the tangent. M... Oh, don't need that. Y minus f of 4 is 5/3. My slope of the tangent is negative 5/9. And the x minus 4. So there is the slope of the tangent, or the equation of the tangent. All right, and so that's the end of video 2.